Yeah, good morning. Myself, Ms. Aishwarya Kannan, Assistant Professor ECE. So I'm going to handle EC8094 satellite communication for you. So here we go with Unit 1, which is the satellite orbits. So in the syllabi of satellite orbits, we have various Keplerian laws that deals with the satellite communication and the other Newton postulates as well. Orbital parameters, orbital perturbations and all those stuff which keeps satellite communication an efficient one. So here we are going to see about the various station keeping maneuver for keeping satellites in its perfect orbit, in its perfect plane, that is the latitude and longitude. Then we're going to see about the look angle determination, wherein we have specific angle like 75° north and 105° west longitude to make the satellite ahead of losses. There comes the limits of visibility into picture, where probably we might hear about various eclipses like the solar and lunar eclipse, which makes the limit of visibility of a sun that falls behind the moon or ahead of Earth, where the reflection of sun gets very meager. So in order to eliminate that, we have certain launching procedures in which you're going to see about Despin structure as well as the cylindrical structures. So here we go. So satellite, what it is. Why specific to satellite communication while all other communication find its advantage? How about the ease of usage? What are the laws encapsulating the communication process, and further with the orbital perturbation? What is a satellite system? As we know, a satellite is something that is placed thousands of kilometers ahead of Earth. We have two certain types of antenna that is being placed, one at the Earth station and other at the satellite. So the line that gets from the Earth station to the satellite is called the uplink, and it works on a frequency from 5 down to 4 gigahertz. The upper frequency is 6. The down frequency is 6 minus 2, which is 4 gigahertz. And in similar way, the downlink frequency goes from 16 back to 14. So while using that type of satellite systems, the ease of communication for both the transmission and the reception of the terrestrial communication traffic held in its place. How a satellite works? As the structure depicts, a satellite rotates in an orbit around the Earth station, which is pulled by the gravitational force, which gets balanced by the central revolving satellite. A satellite generally holds with an orbit which is an oblate spheroid. And finally, we are going to see about the various laws that gets encapsulated for the satellite to work at the specific feature. We have three types of Keplerian laws. The law of orbits, where all the planet that gets rotated around the Earth tends to be an elliptical path. Next is the law of area, where a line that connects a planet to the sun sweeps out equal areas in equal periods and equal planes. The law of period states that the mean body distance, that is A, which is directly proportional to the mean motion, that is the gravitational force that gets exerted on the satellite. So this is Kepler's first law. The orbit of any small body about the larger body tends to be always an ellipse, with Earth as one of its focus. The Keplerian second law, as we have seen, here is area 1 that gets depicted by the green color line, and blue represents area 2. So when the area tends to be increasing, the sweep tends to be also increasing with the direct proportion of time. Newton's third law and Kepler's third law holds good because both tends to be the force exertion on a body. If the body or the mass tends to be higher, the force exertion is also tends to be higher, which is F is equal to ma. Next, we are going to see about geosynchronous orbit. What is geosynchronous orbit? Geo in the sense, if there is no inclination or eccentricity, if the value tends to be non-zero, we call the orbit to be a geosynchronous or a geostationary orbit, wherein it gets exactly circular, not an elliptical. And moreover, it is placed at the correct altitude, wherein the plane of equator goes with a zero inclination with respect to the equator across its globe. We have seen about the orbital perturbations, and here we go with the orbital parameters. The apogee, which is the point that is very farthest from the Earth. Perigee, the point that is very closest to the Earth. The line that gets connected from the apogee to perigee is called the line of apsides. Then we have the ascending and descending nodes. Ascending node AN represents the movement of the orbit with respect to its equatorial plane from north to south, and if it goes reverse, it is called descending node. The line that gets connected between the ascending and descending is called the line of nodes. To make these line of apsides and line of nodes to fall in its place, here we go with the two type of angle called the angle of elevation and the azimuthal angle. It has been measured with respect to the geographic north plane to the projection of satellite path on the horizontal at its Earth surface. Next is the orbital perturbation. So perturbation is nothing but any disturbances that gets to the Earth situation due to the gravitational force of Sun and Moon, the power or the noise that get exerted due to the environmental conditions, the heat aberrations and all those stuff which causes the disturbance and make the orbit not to be in its right position. So that we called an orbital perturbation. So under ideal condition, we consider the orbit as to be an ellipse, but the properties will not be constant with respect to time. It will not be zero. There will be some tolerance value that makes the station keeping maneuver to find its right place. So for lower Earth orbit satellites, the atmospheric drag, which is another important disturbance, also find its place. Due to the longitudinal changes, that is the path from the north direction to south direction, we call the effect to be the effects of Earth oblateness. We take an example of an egg. The size of the egg looks like the size of the orbit. So the equatorial radius will not be constant, and it takes more than 1 day or 365.4 hours to rotate the sun and the earth with its perfect sphere. So with this, we are going to see about the specific property called the mascons. The mascon is nothing but a beacon signal which makes the ship or some object that gets very distant to find its right place. So these non-regular features of the Earth leads to the non-uniform gravitational field. Thereby, the force on an orbiting satellite will vary with its position. Thank you.